Okay. So what do you think? 5 out of thumbs. Yes, is it enough information? No, it's not enough information. Okay, so I'm seeing a lot of no's. So I'd like to hear about it because did you already draw the picture? And the only thing we know for sure is 2 points. We have f of 1 is like down here, and f of 5. Put a 5 here. So 2. Okay, so you're saying it's not enough information. Why is this? Lydia?
Probably because, like, it could either be like 1/x, so like there could be like an asymptote that like prevents the 2 points from like connecting. Like we don't know exactly like the equation of the function.
Okay, so where would that asymptote have to be to kind of mess up this idea? I'm not talking specifically, but there's a region. I think it would have to be like where
X equals 1 and x equals 5.
do we agree with that? If there's an asymptote somewhere between that x equals 1, x equals 5, then there's no guarantee that there is a 0. So yeah, I like what you're saying. Like it could just be 1/x shifted over in this case. Yeah, we have a point up here, we have a point down there, but there's something in the way of like connecting them because there's a big break in this function. So have you studied an idea like this before? Have you talked about this kind of idea? Or did anyone have a different reason why there doesn't have to be a 0 for this function? Okay. Now, if I change this a little bit, and is continuous on 1 to 5. I don't know if you've studied this word continuous, but does it make sense just kind of like as a feel for it? This kind of changes things, doesn't it? Continuous means you could draw it without lifting your pencil from the paper, right? There's no break, there's no asymptote or anything. So if this were the case, then the answer would be yes, for sure there is a 0. Do we know where that 0 is? We don't know exactly, but we know that it would be, what's that? In between 1 and 5. Is there only 1 0? There could be more, right? How many could there be? There could be infinitely many. But if we could maybe imagine 3, it's just something like this. If it's continuous on that interval, then we know that because one value is below the 0, the other one is above, that's somewhere on there. There is at least 1 0. So if it were continuous. None of you studied this idea before, huh? Algebra 2? There are three words that may have come across your teachers' lips when they were discussing this. Intermediate.
Oh, okay.
IVT, intermediate value theorem. Seems like, how many of you heard that idea before, intermediate value theorem? And maybe you discussed it for about 3 minutes last year or something like that, or maybe shorter. It just kind of came out. So I just want to remind you of that idea because we're studying functions and I wanted to see if you could place that asymptote right in there. And you did. Nicely done. Okay, so today what we're going to do is I'm going to finish up the packet. We will get, and then you'll have time to work on tonight's homework assignment. And if you didn't finish last night's, speaking of the last homework assignment, would you check in with your neighbor about how long it took them to do?
Our third.
Let's figure that out today. We have time.
Yeah.
Sometimes
Yeah, sometimes I learn
Well, like, between that. It's like 10 questions. With that, it's
Oh,
like 8 or.
Okay.
oh, yeah, like when it's like eight, I guess.
So my question for you now is, were you able to do it in less than an hour? Anyone able to do it in less than an hour? Do it now, okay. Did it take anyone longer than 2 hours? So between 1 and 2 hours in general, some people took a little bit less. They went doing less than 30 minutes. This one. That's a tall order for this one. I know that there are a lot of parts. No, don't be sorry. I want to gauge how long it's taking you because I don't want to overwhelm you with assignments, of course. I just want to see kind of where we are. Yeah, so was it closer to an hour or closer to 2 hours?
Right.
Maybe an hour and a half. Like a sweet spot right in there. Okay. Is that counting breaks? Was that like work time? Work time as well. Yeah, I do recommend that you sit and start at a time when you have a good amount of time to do your work. And if that time is 12:30 a.m., please choose another time to do your homework. I don't want you doing your homework that late. I'd rather you do the homework late than stay up until 2 in the morning to do your homework. So please keep that in mind. It's tough to balance your schedule. I know the life of a Harvard Westlake student is packed. I appreciate the efforts you go to get it all in. Please discuss before we actually make the equation test. What are you going to see in your function? In the algebra of this function? Generate this graph.
Oh, it's just. It's a base. Oh, there's no, these guys are plus 3. It's like the easiest one is.
Yeah, X plus three, X.
Right. 3. This is the chat, by the way.
Oh, it's a cut.
And then.
It's poorly, definitely poorly done, but it's a tough.
Also, your birth certificate, like, there's sense, right, to the number. There's 2. Yeah. The one that's actually one that goes. Yeah. And there's one that touches.
Gonna just.
That's why. You also.
Like this. Or not.
There's an absence or any other.
Yeah.
Oh, this is just saying.
Yes, it would be like.
Okay, what's the thing you need to notice before you start building this function? Asymptotes. Specifically, we have
Two vertical.
two vertical asymptotes, which you're going to find on the
Denominator.
in the denominator, right? And also, we know that there's a denominator because this is how do you know it's a rational function? Because it has a vertical asymptote. So there's going to be a numerator denominator. So there's going to be a couple factors in the denominator. And what else do we know?
The x-intercept.
We know x-intercepts. Nice. What else? Horizontal asymptote is what's that?
Y.
Yeah, y equals 3, which means
And the ratio is 3.
is it top heavy?
It's balanced. Or
It's
no,
balanced. It's even. Okay. So x-intercepts. Okay, let's see if you can put this together.
Base is exact.
Yeah, it's really.
We could try to find it, see if
And then get
there's just 1. I would. So it's the. Yeah, that was my two costs.
Negative 2.
So that's it's great. This one's I think 8 pounds
Oh, gosh.
or so. Okay, yeah, it's definitely 3 years. So, yeah,
Because
you-
But is it?
this is 0 and you multiply it out. The only x intersection is 0.
That's how
That's three.
it's
How
never mind, wait.
It looks like it touches both. Anything crossing through negative becomes 0, then touches and bounds.
Yeah, that's not. Yeah. I don't know what I'm gonna do.
One of them squared, right? It's all here. It's starting with first. Yeah. And then it's balance. So. And then x plus 3 right is squared. It's just balance.
Yeah, it's just still.
It's also squared on the
While also having punch.
It has to be right. Once this is 0, this should be squared. Yeah. Yeah, go around there. Well, yeah, I understand. I thought that through the horizontal. And yeah, obviously. But eventually. That's. Oh. And you got it. I think this. Yeah.
Yeah.
Nothing. 4%. Yeah.
Yeah.
It is not, it's just, like this. But there's the non-functional. Oh, yeah, that's. Yeah, this thing. Oh, you know.
No, I'm just like looking.
Are we ready to talk about it? You want a little bit more time?
Yeah, a little bit more time.
I'll give you 30 seconds.
There's no. I don't think that's.
Nine. That's a good.
It has to just.
Yeah.
Thank you. Sometimes it just kind of lines up. Think about 2015, what a perfect date that would have been. Okay, folks. Make sure to have this. It's an equation. Make sure you have an equal sign on your paper. On the left, equal sign, what should be on the left? Either f of x or y. But let's get used to f of x. And f of x and y could be replaced with one another. They have the same thing, basically. Okay. I need some help. Yes, I'm here. Okay. Just one thing in the denominator. Let's spread it around a little bit. X plus 3. Do we agree? Okay, thank you. I need another thing. Yes. X minus 4. Are we good? Okay. I need something else. X minus 4 squared. Is this true? Would you please check in with your neighbor? Why would it be x minus 4 squared?
Because it's approaching.
Show me why. Show me with gestures why it is squared. Yeah, we see this. That makes it a even multiplicity. Good catch. Yeah. Little nuance. Should the other one be squared?
No.
Could it be like, it technically could be like even more than squared, but.
Yeah, it could be cubed or to the fifth or something. Oh, you mean this one to the fourth? Yeah, as long as its number is even. But we want to keep it as simple as possible. So when given a choice, don't go crazy. Don't be like to the millionth power. Okay, so you got that. Yes.
So why would the squared be on the x minus 4 instead of the x plus?
Let's see what's happening with this one compared to this one. The asymptotes are going in the same direction. Not the asymptote, sorry, the behavior around the asymptote.
Oh,
As opposed to the other one.
And.
So the first one, it could be x plus 3 to the third power. Again, keep it as simple as possible. Don't do anything crazy unless there's a reason to. And for the crazy's sake is not a reason. Okay. Yeah, Lydia, you want to continue? Okay. Anybody else want to give us something else here? A little something? Yeah, David?
I just be safe, you should probably put like factor out in front, just call it an A. But we don't know it yet.
Okay, nice. And I'll talk about this in just a minute.
I guess the-
Just on top.
And then on the top, it bounces on one, so there's an x minus one squared.
What do y'all think?
Yeah.
Me too, me too.
Yes. Yeah, it has to, yeah. Well, it has to bounce, you said it needs to be, is it balanced now?
Not yet, not like first, there's none of it. For, because we don't, it doesn't, if you know, it's for the next step.
Yeah, and what is the next step? We need an x plus 2 on top. Now I'm going to take away this 8, but David, I appreciate you mentioned this. And let's see. I see that it's balanced. Cool. I see asymptotes. I see y-intercepts. Oh yeah, we need that horizontal asymptote of 3. Okay. So should I just stick a 3 up there?
Yeah.
Is that enough? I think that'll do it. So we could have just put an A there, but I think just 3 for now. Right now, we know exactly what that number is. Do we miss anything here? I think that's it. That's right.
Why does the, I guess the curve on the far left go that fast? That something?
Good question. Like, why doesn't it do this? That is out of the scope of this class. So it's nothing you have to be concerned about it right now. As far as why. But it'd be interesting to see if it's true. Like, if we cut that into Desmos, does our function actually go below that? What's that? Well, let's do the next one. Then I'll talk about it one-on-one. I'm happy to discuss with you. But yeah, I think that in terms of my expectations, everything is here. Like if I see this 100%, would it be a good idea to multiply these out? No. It'd be a waste of time and you'll probably mess up. So 2 bad things. So just leave it like that for perfect score. Okay, one more. Da-da-da-da-da-da. Oh.
Be negative. Maybe.
I don't know why you dropped these. That's something.
Yeah.
So. That's fine.
Like if like have like X, it's like gonna go up for all of this. But how do
Oh man, this is a tricky one.
Oh, that's great. It's just. What was it?
I don't even.
Oh, right, so.
Okay. X minus one Q,
Oh, is it up here?
and then X.
Wait, let me sit down here.
Or X minus.
Oh, let me go with the asymptotes. That's the way we do it. And that's. Yeah.
I'm just gonna read.
I think.
Oh, no. It's on that. Not to go.
Okay. I think this. English tip was version. Yes.
Yeah. Okay. So I'm gonna assume that you made a fraction. I assume that you wrote f of x or y. I'm gonna let you do the rest. I'd like some suggestions from people who didn't give a suggestion yet. They get first priority. So what goes where? Yeah, Christine. Okay, x plus 1 squared like that. Okay, do we agree? It's squared because
There you go.
you see that, right? See that. Okay.
Yeah.
Thank you very much. I need someone who hasn't given us an answer yet. Yes, Sophia.
That's what it is.
Where is it? On top or bottom? Bottom, X. As X minus 2 squared, of course, because we see same direction. Thank you. Okay. Are we done?
No.
So I need someone who hasn't given us an answer yet. There's still a few people who have not given us answers yet. Your first priority. Anything? Yes, Holland. X minus 1, that goes top. Are we good with that, everybody?
You tell one and down. I didn't know.
Oh.
You-
Really?
Because helps.
Yeah.
Yes.
Yeah.
Why would that be cute?
You need a balance.
A little swagger.
Reach the board.
Hello, John.
Maybe. I'm not sure.
This is the intercept, which is.
Say that again.
Because it crosses the like the cubic thing on that graph, it's just the explanations. Y equals.
It kind of looks cubic. I'm gonna say that if it's cubic, it would look more like it's tighter. It would look something like this. That would be cubic. And it's pretty close. And it's a good assumption to, well, it's a good question to think if it's cubic. I'm gonna put a little question mark to see if things balance. It's definitely not squared though. Do you agree with that? It's definitely not squared. Okay. Okay. So that's, yes, Henry. X minus 3 in the numerator. Are we good with this? Okay. So, did I miss anything? Yes.
X.
Good question. I don't know. Why would we have to do that? I'm not sure. If we had to flip it over the x-axis, how would we do that? Put a negative sign in front. Yes.
Right now, let's say you put a really big number,
Mhm.
million.
Okay.
It's gonna be positive. That number is gonna be positive. Cubic.
True, everything.
Yeah.
Yeah.
And if you look at where it's trending towards, which is why it's one, that's positive. So, and if you put a negative out there, that's.
You
no
lose
one's
that.
fine.
Yeah. Yeah, so but maybe there has to be some sort of flippage. Maybe flipping over the asymptote. Do that.
Or, you know.
Oh, it just, as long as it's going the same direction. As long as it's going the same direction.
Sounds simple.
Good point. These are both going negative in a negative direction. You don't have to account for that negativity. You don't have to account for it. It'll all work out in the wash. These are going the same. These are going the same. Square. That's all I have to think about. So thank you for bringing that up. There is one thing that we haven't accounted for. There's something very obvious on here. Well, as it is, I think we nailed the horizontal asymptote, didn't we? If it's cubic. So I'll put this there. Yes. The y-intercept. It's a very clear y-intercept, isn't it? And the last one is like, they obviously don't care about that y-intercept. There is one, it's a tiny y-intercept, but they're not saying it should go through this point. The next one is very clear that the y-intercept is 1. So does that work out? How do we check the y-intercept?
Yeah, it's just.
Yeah, I'm gonna find f of 0. So if I make that, it's gonna be -1 cubed times -3 over 1 times 4. Is that right? Which equals 3/4. But we want it to equal 1. So this is what David was saying before. This is where this comes in handy. We need to add something to this without changing what we have. Yeah, we need a constant multiplier. A is a good one. So I keep an A right there. So this is also A, and then this has got to equal 1. We want that to equal 1 specifically. Which means that A is 4/3. Did this mess up the horizontal asymptote? If I put that, and I'm going to put in like this, 4/3. The asymptote is gone. What?
Why?
Let's get into the 1660.
Okay.
So if you get to this 4/3, if this is a test question and you've dealt with this, and you have a good B plus A minus answer so far. A good B plus A minus answer. But you're right, it doesn't all balance. I can't give you a perfect grade on this. Wait, on this, not quiz, on this test.
Like,
Yeah.
So how can we change
A to the bottom.
A to the bottom? I'm not sure that would help, but thank you for playing. So what we have to do is we have to go back to our assumption, because this cube is kind of sus. Kind of sus.
They have to be odd.
It does. Well, no, it does have to be odd. So I'm going to take away the 3. I have to take away the A also. And instead, we recognize that the top has to be degree 1. The top has to be degree 4, doesn't it? Okay, it has to be, which is why it was really nice to have that cubic in. It was nice. But it's not quite a cubic behavior. It's kind of like going straight through. It's just going straight through. It is the overall, it's an arch, but it's not the point of inflection for it doesn't to me appear to be happening. So we have to account for this another way. And then it is up here. How can it increase the degree of a polynomial without increasing the number of zeros? Thank you. I just read it myself. Yes.
X squared minus 1. Those are x cubed minus 1.
Oh, this one? X cubed minus 1. Why would it be x cubed minus 1? That?
Well, the solution would be -1.
Solution is -1.
Yeah.
Okay.
And it's a cubic, so that solves that.
Okay. Wait, say you kind of said something quickly that I want to steer what's going on.
X cubed term -1.
Okay, so let's analyze this. I like where you're going. So you know that this is x minus 1.
Oh. Oh.
Maybe, but you mentioned something about this. Something else. You said 1 is one of the zeros, and then you said something else about it. 2 of the zeros are imaginary. I like it.
Oh,
So what you've done here is come up with a very specific way to get the x minus 1. I think it's really cool. I'm going to recommend at the top, let's put another factor that has, like you're saying, no real zero. To do this one, x squared plus a. There's our a.
Wait, whoa.
Think about that. If a is now a positive number, if a is a positive number, will that result in any x-intercepts?
No.
It won't.
Imagine.
We get to keep our horizontal asymptote. Right, keep our horizontal asymptote. And we can arrange it so that if we have the correct value, we can still have what needs to be true.
But I would never.
Yeah.
This allows us to manipulate it so that we can calculate
We would see how
that has a y-intercept of 4.
I'm sure.
Let's try it again. Right, so this is a stretch for sure. So I'm gonna go back to this.
Well, not.
Oh, you haven't taken a test in this class yet, huh?
Wait.
Am I doing this right? Did I do that right? So we still get
Easy with a point.
yeah, we still get 3/4 a equals 1, we get A equals 4/3.
Horizontal axis with all.
4/3 goes right here.
Oh, it puts all the constants at the top.
Yeah.
Oh,
Right,
it's crazy.
I know this is a big stretch, but notice.
We got 6 left.
Notice that this doesn't result in any real zero. But we have our one, we have our three, everything is still.
Like a standard test problem.
I would say this is standard, this is, and this type of problem is standard, but this feature of the problem is the upper echelons of what.
So
That's like an honest.
so it wouldn't like show up on the test.
I could, especially now that we've gone over it. But yeah, to just surprise you with it on a test without ever having seen anything like this. That would, I think, be.
But it
Oh,
will be.
But now it's easy.
Now.
We'll see.
Now.
But get back to you about what you see on the test next week.
I'm pumped. I don't know about you.
As you should be.
Yeah, but like,
Before. Keep putting them in cabinets.
no, I
Yeah.
want to like look out
Can we
for
get
it
more
and
practice?
Yeah, I agree.
Yeah. And it's on your homework actually, so I'm gonna give you some time in class to start on the homework.
Sound good. Very.
On Pearson? Yeah, yeah, on my math lab. Pardon?
We're out the things, I think.
Oh, yeah, let's do that. I'm gonna close the lesson down for the day. By the way, if you didn't understand what just happened, make sure you